so our job here is to go through and find basically all the stuff we talked about the last few days. So I'm going to do it like one level at a time. So that's my original equation. What the original equation tells me is if there are any asymptotes on the graph. So are there any horizontal asymptotes on this graph? There are. Horizontal asymptotes, you look at the higher power. The higher power is tied, right? You got next to the first on top, you got next to the first on the bottom. So if they're tied, you look at the coefficients in front of those. So 1/1. So there is a horizontal asymptote at y equals 1. Vertical asymptotes happen when the bottom equals 0. So if I set x plus 2 equal to 0 and solve that, there is a vertical asymptote at x equals -2. So that's kind of my first, original equation information. Then I'm going to go to the first row. And I'm just going to type in my calculator. Did that a second ago, but I forgot it. So it's 2 over x plus 2 squared. The information I want from the first derivative is where is the original graph increasing, where is it decreasing, and where are there any relative max or relative mins. So the first thing I'm going to do there is find critical points. Remember, you find critical points by setting the top and the bottom equal to 0. So if I set the top equal to 0, here 2 equals 0 never happens. So that's nothing. X plus 2 squared equals 0. Remember, that squared doesn't really mean anything. So we end up with x equals -2, which I already know that's a vertical asymptote. So is it possible for -2 to be a relative max or relative min? It's not, but we still might get a change there. Like, it still splits the graph, and it might be increasing on one side, decreasing on the other. It's possible. It's important. It just can't be a relative max or relative min. So I'll do my number line, set up my intervals. You're picking a point from that interval, and you're plugging back into which level? First derivative. You plug back into the level that you got the point from. So if I say, like, pick -10, I plug -10 in here, and so I plug it into the bottom and square it, it's going to be positive. 2 divided by positive is positive. So y prime is positive, which means y is increasing. So over here, I'm just kind of keeping a summary list over here. It's increasing from -infinity to -2. With me? Do the next interval, so -2 infinity. Let's say I plug in 0. 0 plus 2 squared, that's positive. Positive divided by positive. So this is also a positive derivative, which means y is increasing. So it's increasing from -2 to infinity also. It's not increasing at -2. So it's not like the entire graph. It's not increasing at -2. Why not? Like, what is there that prevents it from being increasing? It's vertical asymptote. So it's not increasing at that one spot, but everywhere else, basically. It's not decreasing at all. So relative max, we need to flip from ink to dec. Well, that never happens. Relative min, we need to flip from dec to ink. Well, that never happens. With me there? That's like your first derivative information. We're going to repeat that process with the second derivative, and that's going to tell us about concavity. So where's the concave up? Where's the concave down? And where are there, if there are any, points of inflection? So second derivative, again, I'm just typing it in. I'm not going through and doing all this by hand. It's faster, less likely to make mistakes. Kind of end up at the same spot. I mean, it's different values, but if I set the top equal to 0, I'm not going to get anything. If I set the bottom equal to 0, what am I going to get? I'm going to get -2 again. So I'm setting up my number line. Still going -infinity to -2. -2 to infinity. Now plugging back into which level? Second derivative, because that's where I am. And what does the second derivative tell me about? Tells me about concavity, and that's what I want. So that's where I'm at. So let's say I plug in like -5 here. Well, -5 plus 2 is a negative number. A negative number cubed is a negative number, and then a negative divided by a negative is a positive. So y prime is positive, which means what is true about the original? Concave up. So then we are concave up from negative infinity to negative 2. Repeat that in this interval. So let's say I plugged in 0. 0 plus 2 is positive. Positive cubed is still positive. But then a negative divided by a positive. So here the second derivative is negative, which means y is concave down. So we're concave down from negative 2 to infinity. And I do have a concavity switch, right? So there's a point of inflection. There's not one. I know I'm just going to write like kind of where I would be going. So I would start off by going, okay, yeah, there's a point of inflection at negative 2, comma, something. And what level do I plug back in there to find out the y values? The original, and if I did that, what would happen? I get 0 at the bottom, right? So I'm stuck. It's not really a point. And then I'm like, oh yeah, wait, never mind. There's not one. It's a vertical asymptote. Then, so this is kind of the new part. We're going to combine the number line. Well, let me stop there. Are there any questions on what I've done so far? So 3 levels. Those 3 levels up there, they each find their own little things. I'm going to combine the 2 number lines. So in this case, I only had 1 point, negative 2. That goes out there. But if you had different points on each number line, you would put any point that you had on any number line down here. On the top, I am going to write whether we were increasing or decreasing. So increasing here, decreasing there. I guess I forgot to write these up here. You don't really have to, but it's probably good. Oh yeah, sorry. Thank you. So increasing, and then we have concave up here and concave down here. And then this is where we get into those shapes. So if we are increasing in concave up, I always start with like the concave up or down, so I have to draw those shapes now. Basically every graph consists of those shapes just put together in some fashion. Or a line. But most graphs are something like that, like some wiggles just put together. So I got to figure out what shape this makes. Increasing and concave up. So I always think about the concave part first. So concave up is a U. So this concave up part is going to make a U. And I want the increasing part of the U. So do I want the first half or the second half? Well, the second half. So then that tells me that this shape here looks like that. And then here is increasing and concave down. So again, if you think about the concavity part first, concave down is like the end. And I want the increasing part. So now do I want the first half or the second half? Now I want the first half because that's where it's increasing. So it looks like that. Now, we're going to make a graph. So if there were any points that we knew, a relative max, a relative min, or a point of inflection, I would put those on the graph. This example didn't have any, so we don't have any points to put on there. I do know asymptotes. So y equals 1, there was a horizontal asymptote. And at x equals negative 2, there was a vertical asymptote. And then we have to fit those shapes in to this graph. A lot of times there's points to connect, and we'll do a couple examples of that for sure. This time there's not really points, so you just gotta kind of put things in the right spot. There is some wiggle room, but there's certain things you have to be aware of. So to the left of negative 2, I tried to line these up, so that's negative 2 on the number line, that's negative 2 here. I have to draw this shape. Well, I also have to respect the asymptotes. So for example, if I went down here, is that really respecting the horizontal asymptote? It's not. The horizontal asymptote should level the thing off as it goes that way forever, right? This just kind of like blasting right through it. It's leveling off somewhere down here. At the same time, if I went way up there, that's leveling off like too soon. So where I want to put this is right there, so that it does respect the horizontal asymptote that's leveling off as I go this way, and the vertical asymptote is getting bigger as I get closer to that. And as far as like how you shape it, that part, you know, if I did that, that's still correct. If I do this, that's still correct. So you have some like wiggle room in there, but you have to like be within the asymptote. Does that make sense? Same idea over here. This is the axis, so this line doesn't really matter for our drawing. This asymptote is what matters. So I have to draw this shape and respect the asymptotes. So again, like I can show you what's wrong. You know, if I do that, my horizontal asymptote would be up here. It's not supposed to be up there. It's supposed to be down there. So what I just drew is too high. If I drew, you know, something like that, well now my asymptote is like the axis, but that the axis is irrelevant in this. It's that we want. So what you want is something like this, where you're getting closer to the vertical asymptote as we go down and closer to the horizontal asymptote as we go up. And again, you have some wiggle room. You know, if yours went like a little steeper or a little shallower, like no one's gonna mark that wrong. That's just kind of personal drawing. Questions on anything I just went through? It's a big process. Your quiz on this stuff will be like, there'll be like 1 or 2 of those, plus other things. But it's not like you'll have like 10 of these because there's just not enough time. Questions on that process anyway? I can go over it. Alright. I don't think it's too bad actually. I really like them. I think it's cool that we can like recreate the actual graph without, you know, graphing it. So let me get out the packet. I just have them on here. We're not going to do all 10 today for sure, but I'd like to do at least one more example with you. And then we'll do, you know, some today, some tomorrow. Let's do number... let's do number 7. So the format I just showed you is just kind of my style. It seems to work well for people if you want to organize it this way. You know, I'm going original level. Here's what that affects. Derivative level. Here's all that information. Second derivative level. Here's all that information. And then I kind of combine it at the end to do a number line, and then make a graph. I think that's helpful to organize it that way. So if I'm looking at this one, number 7. Are there any asymptotes? There are not, because there's no fraction. So it takes care of that right away. For the derivative, you can do it by hand. You can go ahead and type it into your calculator, whichever you want. my derivative came out to be negative 0.605 over x minus 3 to the 2/3. So what do I do with that? Set the top and bottom equal to 0, right? So if I set the top equal to 0, I get nothing. If I set the bottom equal to 0, what do I get? I get x equals 3. The information I'm trying to find from this level is increasing, decreasing, relative max, relative min. All that comes from the first derivative. Some of you, I think, could probably say, hold on, I can tell you what it says. So instead of this negative 0.605, does some of yours say negative 6 to the 1/3? So that's just a number also. If you set that number equal to 0 and solved it, there wouldn't be any solutions. Do you want me to show you how to switch it though? Make it decimals? I mean, just if you want to. So if you go to, so this one is exact. The calculator's not going to round the negative 6 to the 1/3. And this one is approximate, so that answer. Switch back and forth. If you hit mode, scroll down, you got to scroll a little bit past the bottom of the screen. You get to this exact approximate. If you hit right arrow, you can choose. So hit whatever you prefer. I think approximate's probably good. Then hit enter, and then you hit enter again to save it. Then you can switch back and forth if you want. Should I go through that again? So mode. Scroll down. It's down past like the first page. You're looking for where it says exact approximate. Hit right arrow. Pick the one you want. Hit enter. And then you'll notice it says enter equals save, so you gotta hit enter again to save that. Anyway. So x equals 3. That gives me a point to put on my number line. So I'm going negative infinity 3. Negative infinity. You guys okay? Yeah. Do you need help finding something? You got it. Alright, I pick a point from this interval and plug it back into what level? First derivative. You plug back into the level that you came from. So if I plug in, say 0 here, so 0 minus 3 is a negative number. Then you do the root. So the third root of a negative number is a negative number. Then you square it. Now it's positive. Then you have a negative divided by a positive. So in this case, y prime is negative, which means what's true about y. If the derivative is negative, y is decreasing. Good. So I can fill that in my little list over here. We're increasing from negative infinity to 3. Same process, but pick a number between 3 and infinity. Let's say I pick 10. 10 minus 3 is positive. The third root of a positive is still positive. A positive squared is still positive. And then a negative divided by a positive is negative. So the derivative is negative again. So y is decreasing again. So we're done with the first derivative level over here. So now I can go, okay, well, it's never increasing and it never switches from one to the other, so there's no relative max or min either. All right, now what? Second derivative. And that's going to find for me, or we're going to go through and find where we're concave up, concave down, and if there are any points of inflection. Yeah, I'm not going to do it by hand. I'm at the second 404 over x minus 3 to the 5/3. You see the same thing? So if I set the top equal to 0, what happens? Nothing. Set the bottom equal to 0, what do I get? I get 3. I keep forgetting to do this. So back up here on this number line, I should be writing decrease. I mean, you technically don't have to, but that's the point. That's why I made a number line. So now I can write decrease up there. So now I'm going to have a second number line for my second derivative here. It's still going to be 3 that goes on there. My intervals are going to be the same. And then your intervals won't always be the same, just the examples I picked here, they are. But I plug in, I pick a point in this range and plug into which level? Second derivative. Plug into where you came from. So let's say I pick 0. 0 minus 3 is a negative number. The third root of a negative number is negative. A negative number to the 5th power, still negative. And a positive divided by a negative, still negative. So your second derivative is negative, which means what do we know about the original? Concave down. So we're concave down from negative infinity to 3. So repeat that with a number between 3 and infinity. Say 10. 10 minus 3 is positive. And you can see why it doesn't matter what number I pick, right? Like, I don't care what number I pick in this range. If I plug it in here and subtract 3, it's going to be positive, isn't it? It doesn't matter what you pick. If you have a positive number, third root of a positive number is a positive number. To the 5th power, still a positive number. Positive divided by positive, still a positive number. So the second derivative is positive, which means y is concave up. So do I have a point of inflection? This time I actually do, because this is not a vertical asymptote. So I have a point of inflection where it switched. So we were concave down before 3, concave up after 3. And so these parentheses get a little weird, but these represent like intervals, right? This is going to represent an actual point on the graph. Which is your question? What? What? Did I do it backwards? Oh, yeah. Man. So my work here is right. I just put it in the wrong spots. Concave up is 3 to infinity. Thank you. Concave down is negative infinity to 3. Not bad, thanks. So the things that go in these spots, like the increasing, decreasing, those are going to be intervals, and the concave up, concave down. The relative max, relative min, and point, you're looking for an actual point. You're looking for a y value that you can put on your graph and be like, here, I know it goes through this point. So this one I want a y value. So what level do I choose to get the y value? The original. So we plug 3 into the original. 6 times 3 is 18. 18 minus 18 is 0. 0 to any power is 0. Negative 0 is 0. So this is a point on my graph. So I can go to my graph now and be like, all right, I know at least something. At least know it goes through that spot. 3 comes 0. Right. Or not. I used my, someone said shape. So I'm going to get my big number line and put everything I know on that number line and try to get my shapes. I'm going to try to connect my shapes to my dot. Make myself a graph. So on top, I know it was decreasing and then decreasing. On the bottom, we were concave down and then concave up. So again, think about your shapes. So concave down and decreasing. I know concave down makes the n. If I want the decreasing part of the n, and then the first part of the second part. The second part is going to look like that. I gave up is the u. I want the decreasing part of the u, the first part and the second part. First part. So those are the shapes that I want. So I basically need to pick up these shapes. Like if you could click and drag, that's what you really want to do is like click this shape here, bring it up here and put it on the graph to the left side of 3. So do you see how I want to put the point right at the bottom of that to match that up correctly? So I'm clicking this shape and dragging it, and I basically want to connect the dot to the bottom part of that shape. And then the same thing for the second piece. So I want to pick up this shape, and it's going to connect, so this is now going to connect to the top of that dot. And so you're going to get something like that. So keep in mind when you go check the answers, like the size of your curve doesn't really make a difference. So there's, like here's what they have for number 7. And they do put the information there with it, so you can check all that stuff. That doesn't look like exactly like mine, but it's pretty darn close, right? You can tell the shapes are the same. But you know, if you go up a little higher, down a little lower, up a little lower, down a little higher, that part doesn't really matter. It's the shapes that we're concerned with. Alright. Anything in there I can help with? Questions on that process anywhere? Have you do 1 for homework? I don't know which one you have. Let's see. Let's do number 8. The first thing about 8 is to make sure you're not starting in the wrong, like down the wrong path. Remember, this is the same as like 1/3 x to the third plus 1/3 x squared. Don't go do a quotient rule or anything. Although I guess you just type it in your calculator anyways. So I'd like you to try that. It's on the back. You know, get the rest of the class to do it. And then tomorrow we'll just keep chugging away at this worksheet. Do more. Fair enough. Every other class I teach, I tell them to shut up constantly. They're like begging.